first the welcome from the Frankfurt University, please.
Thanks a lot, Bernardo. Muy obrigado. Thanks a lot to the whole EDPS team coming to Frankfurt and making this a great event and bringing very important things to us here at Goethe University. My name is Kai Rannenberg. I'm the professor for mobile business and multilateral security here at the university, and let's say a proud host of this event, especially a proud host because we're doing this for the second time here since 2016. So that means people came here and decided to come back. So it cannot have been too bad back in 2016. And I do vaguely remember what I told 2016. Maybe some of you know. So who of you has been here already in 2016? That's some of you at least who came back, but that means I need to probably tell a bit more about the background of this building that you're in. Some people said, hey, this is a wonderful park, and how can a university afford such a wonderful park and such a nice building? And the point is, a German public university cannot afford this when it would need to build it on its own. It can afford it when it inherits. So how did the university inherit this? And that tells us quite a bit about also what an IPEN is about. Because this building, and also especially the neighboring building, if you look back, which looks a little bit like another brick in the wall, if you remember Pink Floyd, that building is actually, or was built as the headquarters, about 100 years ago, the headquarters of the then largest chemical conglomerate in the world, called IG Farben. Maybe IG Farben rings a bell with some of you. IG Farben is that company, indeed, that was important, let's say, 15 to 20 years later. It is that company that delivered the poison gas, or the poison for the gas, to the German death camps in the Nazi time and in the Second World War all over Europe, or in many, many places, especially Poland, but also some other countries. So IG Farben has made a lot of money out of killing people in death camps. But not only that, and if you're interested, you can see a history exhibition in that other building, beside a very nice Paternoster, which was the new technology in those days. And IG Farben also was a high-tech, very powerful company in its days in chemistry when that was high-tech. It was not only making money from this poison gas, it was basically making money from exploiting the people in the death camps in every dimension that you could possibly imagine. And a chemical company can be very inventive and innovative and into that. And that indeed they did. You see that documented. So not only the people before they were killed, they were working in slave labor camps and did slave labor there for no money, but for good profit. Also, once they were dead, a chemical company can get quite a few bits out of dead bodies. I don't want to go further because then you may never want to have any coffee anymore or so. You can see it in the exhibition over there. But what you see, it was basically it was a public-private partnership between IG Farben and the Nazi government, and you can say it was a full value chain. So all of the economic and business elements and processes that you have were used and to get maximum effect, but obviously for goals that we don't want to support. And it tells you what happens when the government moves into authoritarian, and then businesses are aligning with it and trying to make best money out of it. Second World War ended, fortunately. Germany lost, also fortunately. The US came here and decided IG Farben is a company to be split up into 3 small companies, which are nowadays named BASF and Bayer. You may have heard about them if you research deeply. And another one called Hoechst, that maybe the older ones of you know, that is now Sanofi. But so 3 relatively large companies, but the headquarters were not needed. So the headquarters became headquarters of the US Armed Forces in Europe. And for example, the task to write a German constitution was given to some people in Germany by the then and director of the Army, US Army here for Europe, Mr. Eisenhower. That's why you see an Eisenhower rotunda there and quite a few other things. There are some more anecdotes, but we don't have time for that. And we're going to return to this. When the Cold War ended, the then university president said we should have this building, and for a university building, because of the history, and the history of the ground is so loaded, this should not be forgotten. This should be told and kept, and that's how the university inherited a very nice building and a very, well, rich from a scientific point of view, loaded history. And that's why we're very happy, among other things, to do something which will hopefully avoid these kind of things in future. And we're very proud to host IPEN again. and APF tomorrow also in that package, and to see that the collaboration of this is working. And now I've spent enough time between you and the interesting stuff, and I think I'm going to hand over to the EDPS for the opening speech. Thanks a lot.
Thank you very much, Kai. We will now move to some words from the European Data Protection Supervisor. I call here my colleague Massimo Attoresi, which is works as well on the EDPS, and he will provide some words on behalf of Wojciech Wiewiórowski. Thank you.
Thank you so much. So good afternoon and welcome to our IPEN event. Today, we'll explore secure multi-party computation, a technology with the potential for societal benefit, particularly in the realm of data protection. At its core, secure multi-party computation embodies a deceptively simple idea that multiple parties can jointly compute a result from their private inputs without ever revealing those inputs to each other. Here, several examples come to our mind. Hospitals combining patient data to improve prediction models on diseases while ensuring patient health record confidentiality. Financial institutions detecting fraud patterns across borders without exploiting client data, or governments cooperating to evaluate policy impacts without centralizing sensitive citizens' information. In all these cases, secure multi-party computation suggests a plan that combines working together with protecting privacy by design, that is, computing without exposure. In the context, we are familiar with data sharing has often been synonymous with data surrender. Secure multi-party computation, however, offers a new paradigm where data remains protected even while it's being used. Unlike traditional encryption, which safeguards data only at rest or in transit, it ensures data confidentiality throughout the computation process itself. However, despite its strong theoretical foundations and growing relevance, secure multi-party computation remains at a relatively early stage of practical adoption. Its ethical challenges, performance cost, integration challenges have so far limited its deployment beyond research environments and pilot projects. Let's focus first in the technical challenges. Secure multi-party computation protocols remain computationally and communicatively intensive, driving research toward hybrid designs that achieve a more practical balance between security and performance. Another technical challenge is interoperability. Today's secure multi-party computation implementations often rely on custom frameworks, specialized cryptographic libraries, and unique communication protocols. Integrating them into existing infrastructures, such as cloud platforms or data lakes, is rarely seamless. And then there is usability. For most developers, secure multi-party computation still feels like a black box, powerful but opaque. To achieve adoption, we need shared standards, usable tools, and education that bridges technologists, lawyers, and regulators. Looking further ahead, the advent of quantum computing poses a new layer of complexity. Quantum algorithms threaten many of the cryptographic assumptions on which most of our current society technologies rely. At the same time, quantum technologies might themselves open new possibilities, from quantum key distribution to quantum-safe multi-party protocols. In the coming years, we must think how secure multi-party computation can evolve to remain secure in a post-quantum world, while maintaining the efficiency and accessibility that organizations require. The time to prepare is now. In terms of security, while this technology helps protect the confidentiality of information, it also can create new risks. How to evaluate the residual risks when computation spans multiple jurisdictions, each with its own legal frameworks and threat landscapes? We must also remember that secure multi-party computation is not immune to side channels attacks, implementation bugs, or key management errors. Like all cryptography, its security depends not only on the math, but on the ecosystem surrounding it, the people, the code, the operational practices. As with any cryptography, security depends not only on mathematics, but on implementation and governance, making cross-disciplinary collaboration essential. And that brings us to perhaps the most complex frontier, the regulatory landscape. Our existing privacy frameworks, including the GDPR, were not written with cooperative computation in mind, where no single actor controls the data. Who is the controller when no one sees the full data sets? Do all involved parties need to be considered controllers? Can results derived from secure multi-party computation still qualify as personal data? Supervisory authorities such as the DPS are beginning to deal with these questions, and legal certainty will be crucial for secure multi-party computation to thrive. Without clarity, innovation risks stagnation. Secure multi-party computation is moving from theory to practice and could become a cornerstone of privacy engineering, but progress will require collaboration across sectors and borders. It is important to jointly create the right incentives for mainstream actors so that they can adopt these technologies. In practice, organizations will not deploy solutions that are more complex, more costly, and burdened by regulatory uncertainty unless there are clear benefits and a credible return on their investment. They must recognize it as a value-creating technology, one that strengthens data protection while unlocking new opportunities for cooperation and insight. At the same time, we need common standards guiding how to measure performance, to verify implementations, and certify compliance, ensuring that trust in secure multi-party computation is not only theoretical, but demonstrable in practice. We must also bear in mind that secure multi-party computation is not a magic shield that automatically will make data processing ethical or lawful. It can be a powerful tool, but one that must be embedded in transparent governance, sound legal interpretation, and responsible design. As we move forward, let us remember that the purpose of privacy-enhancing technology is not merely to protect data, but to protect people, to enable collaboration without coercion, innovation without exploitation, and progress without surveillance. On behalf of the organizing committee, I would like to express my sincere gratitude to our esteemed speakers and moderators for their valuable contributions to today's discussion. I would also like to thank Goethe Frankfurt University for their generous support in hosting this event. It is our hope that IPEN 2025 will offer thought-provoking insights and lay the groundwork for the forthcoming annual Privacy Forum, also hosted here in Frankfurt tomorrow. Throughout today's sessions, we will hear from pioneers who have shaped this field from its inception, researchers who have built its mathematical foundations, innovators bringing secure multi-party computation into practice, and policymakers exploring its implications. I invite all of you, regardless of background, to engage, question, and challenge. Because only through open dialogue we can ensure that secure multi-party computation truly serves the public good. Let this conference not only deepen our understanding of technology, but also strengthen our shared commitment to building a digital future where privacy and progress walk hand in hand. Thank you very much, and welcome to IPEN 2025.